So,
And you just do the down arrow. Yeah, there you go.
So first, thanks for inviting me. This is definitely a team effort. Scott, Dr. Spadell, Mark Inns, Mill Thomas, and Juan Grano, and our outreach person, Range, Larry Howard, we've all worked on this. Lots of ranches. We worked on 17 ranches, lots of researchers, lots of graduate students, a real team effort. So the idea is I want to first talk about like why care about distribution. But the thing is, if grazing was like this, if you just kind of mowed it along in a nice even spot all across your ranch, you might be able to do that. You know, eastern United States and small pastures is not a problem. But out here, it's just not reality. There's cattle just don't always climb steep slopes. They don't always go high. They'll use high elevations. Sometimes they'll wander far from water. There's a lot of research been done on that and a lot of issues with that. And one of the issues is if they concentrate in spots like riparian areas, bad things can happen. So like here's a stream that incised, probably at least contributed to by grazing, concentrated grazing by the stream. If you manipulate that and change that, things can get better. So you change this grazing pattern, you do different things, it can get better. So grazing distribution can have a big water thing. It's a big, powerful issue here out in the West. And one of the reasons, too, probably even more practical and for us, I mean, Jerry Holechek, who was here for a long time at New Mexico State, he recommended that you reduce the stocking rate for steeper slopes, something like when you get from 11 to 30% slope, drop the stocking rate 30%. And you shouldn't even consider anything over 60% slope even grazable. And the same thing is on distance from water. Everything within a mile he thought was grazable. 1 to 2 miles, you should drop the stocking rate by half. Anything over 2 miles, it shouldn't even be used. Now, some people have, the only thing is that I got really interested in this because I noticed that not all cows, like Eric said, not all cows have read all of Holechek's great papers. Sometimes they don't always do that. So the thing is, I want to just show you some things here. And one of the ones that's kind of a fun one, we did some work at University of Nevada at the gun ranch in central Nevada. This whole area here is a grazing allotment administered by BLM that they use. And there's some cows using some really steep slopes. And so on many ranches, this type of terrain wouldn't get grazed at all. But here's some cows that didn't read Holechek's paper, grazing it. And so one of the things I want to think about is that this grazing distribution has some real merit. There's about a third of a lot of the big western ranches that aren't getting grazed at all that could be grazed. And that's a big change. I mean, a third. So I get really excited about this idea. I think it's a big thing. The problem is that grazing distribution is a pain to measure. We started out, when I first started measuring, I've been tracking cattle since 1998. It cost about $4,000. The low tech I first started still cost $1,800. It was an expensive thing to do. But there's a lot less one. One postdoc who worked with me, Colt Knight, he developed a collar. He and I worked on one. Cost about $250. And so you can collect some data. And I just want to, so there's always lots of data. The last speaker, the partial things, you guys get a lot of data. But these get them out as well. So here's 15 cows mapped out here on a geographical information system. Tracked for 4.5 months, every 10 minutes. So there's like 19,000 locations for each cow. So it's quite a bit of data. The problem is you got to, for genetic evaluations and stuff, the easiest way, and we've been really struggling with this, is we got to probably get it down to one value. All that, we got to condense all that thing down into one number or series of numbers so we can start describing the trait. Now, one of the things you can really do pretty easy with geographical information systems is estimate the slope of each point, elevation each point, and then measure the distance from the water. Now, those things are pretty easy to get from there, and those are some of the issues that have been identified in the literature and just know practically have an effect on where cows graze. So we can get that and extract that quickly and convert that. This is from one cow, and this cow, we can convert that all to one value. But some of the issues is, when you do that, we collected some data in our kind of naivety. We collected data over, probably the biggest reason we went to a lot of places is we're trying to get a lot of cows. The collars are very expensive, So we just went over and just put cows and tried to keep collars on cows continuous over time. We measured all over the West, from Arizona and Las Cruces here, where I used to be in Havre, Montana, Montana State, all over different types of spots. Now the thing is that once you get this, each spot is different. It's really kind of a multi-dimensional issue, because like steep slopes here, close to water, here, this is actually fairly steep right here, but it's different. If you do higher elevation, steep slope has more of an impact. Because you want to keep, after you've already climbed up a hill, like after you've done 15 more stairs, if it gets steeper and higher and even more things, you'll probably start being reluctant. So how far you go, how much effort you put into it makes it multi-dimensional. One way to think about this is like on, the distance here, we have a 3-dimensional graph, areas that are close to water, red being easily used, blue being not used very at all. If you're close to water, slope isn't near as big a deal, but as further you go from water, it becomes a bigger and bigger issue. Multidimensional. So here we have some data from 2 cows at the Gun Ranch. Remember that's really steep spot from University of Nevada-Reno's. And you have this brown cow and green cow, and there's their absolute patterns. And here's some metrics we can really count for that cow for 2 different cows. Notice the average elevation differs in meters. It changes in slope and different distances from water. Which is the best cow? Who's the best? How do we rank that? It's tricky. It isn't. So we've worked at some different ways to think about that. We could just look at slope and say, well, then cow 835 is the best cow. If we were to look at elevation, cow 858 would be the better cow, the one that we might select. So which is the best? How are we going to handle that? Well, in this place, probably both issues, elevation and distance to water, are probably both important, but we don't really know. And if we go to another ranch or a different even pasture within the same ranch, it might not be the same. So we did some things about trying to integrate it, and it was all my fault. It was all my fault. I did it. I did not listen to Mike McNeil. Scott slapped me in the hand lots of times. I tried to normalize it and put it in a ratio. Just like, kind of like we would do ratios and easy stuff in animal breeding. So we made things where we tried to normalize everything. And so if they were above or below the mean for that contemporary group, if it was absolute mean, it'd be 100. So we tried to normalize, and then we could put them all together, because the units are different with slope and distance and elevation, all in different units. So I tried to think, well, let's just normalize them and throw them together. And I said, I know that's not very good, but it might help. Because I knew it was multidimensional, so we put them all in together. Here we normalized slope, elevation, and normalized distance from water, and put them together. We could average them together because they're in the same units, they're normalized. But the problem is we need to do a lot more work on it. It's probably really naive for us to think that the impact of those are the same at each ranch. And plus, there's the whole issue of being a ratio itself. So one of the things we thought about doing is maybe we could do feature scaling at a point of that, where we could do it by taking the averaging off and subtracting the minimum and the maximum and get that in there for the individual. We could do some scaling. That might be an approach. And another one is that we're tested on it. I had a student working on this, and we're probably going to try to take a look at it. We looked at 4 different ranches, 2 that's really steep, rugged terrain, the Gun Ranch and Montana State University's Thackeray Ranch, and then Corona Ranch, and then Wilbanks Ranch, kind of an intermediate mountainous ranch. And so if we take a look at some of that, we did this, and we did an approach that is used a lot by the wildlife folks for habitat selection. We divide these things up, the pasture, into grids and little spots, and then did a count of all positions within that. And then we use that as our dependent variable, using logistic regression. And then we measured for each one of those spots the slope, elevation, the distance to water and aspect, and used that in to calculate in proglemics of SAS. We used a negative binomial distribution, used the log length fixture, and then we did analysis into that to try and then to predict what is the important factors of these terrain attributes, what makes those become attractive or avoided? More points would be attracted things. So we could predict that using logistic regression in prognomic. And of those 4 ranches I just showed you before, these are the values that are the most important. So the ones with the star are statistically significant, and I have the terrain here, Corona, that Eric just talked about. We need a big pasture there. Slope was important, and the steeper the slope, the more they liked it. Elevation was a big difference. Higher elevations were avoided, and longer distances from water were also avoided, just like you would expect. At the Wilt Banks, which is just on the other side of Cloudcroft in the mountains in New Mexico, elevation was important, slope was important, distance to water was a big deal, surprisingly. And in at the Thackeray Ranch, it was pretty good things. Slope was the biggest issue, elevation was significant, but elevation was actually preferred, which surprised me. Probably because at high elevation was things, they tended to go up there. But sometimes what you think is going to work and what is going to work may not be the same thing. And so each one of these is really different. So we go back to the Gun Ranch, which is really steep, that we just looked at those 2 cows. We said slope is probably the most important. Steep slopes are avoided, higher elevations are avoided, and longer distances of water there. And the cool thing about this value is based, the dependent variable is the counts, so the coefficients are essentially a way to rank the importance of each of those features, which we think is pretty cool. So if we go back and ask that same question with our same 2 cows, so here's our 2 cows. We want to rank them, who's better, who's worse, which we need to know if we're going to do a genetic analysis. If you go back and look at it, we can get some spots here. So if we look at that with their data, with that scaling, it turns out that the green cow, was the best because the lower that value is, the more inefficient she is. So you can use and sum up each of those different points and then be able to rank those animals doing that. So we're going to go try that some more. That's our update, and reanalyze our data. All we need is money. All we need is money. Which is probably going to be the whole thing. I could have done my whole talk and say, just send money, we'll get this thing done. So anyway, we think there's some real chances to use, I think there is. We'll see if it works. There is some real chances to do that with that. So the thing, there's still a lot, I mean, it's a big deal. We have trouble with it. It is a tricky trait. It changes with each spot. But I think I really want to figure out is, there's still some huge differences between these animals. So this is the same little bitty ranch. It's like 26,000 acres, 1 pasture, lots of water. But look at the difference. These cattle were all grazed at the same time, tracked for 4.5 months or 4 months by Wilcox, Nevada, the Todd Ranch. Look at the difference between these 2 cows. Now, granted, I picked the best and the worst, but that's a big difference. If you had a herd of those red cows, you'd be a lot better off and use that ranch lots more evenly than the other cow that just hung out in the flats. So there are some real differences. So I think there's something going on. So we're going to go ask some more tricks. One of the things it's got to be, if we're going to do selection right, it's got to be repeatable. Right? So is this a repeatable trait? Tricky thing, we haven't ever really looked at that as much as we should have, but I have a little bit, so I'll show you some data. Here's a couple of traits at the NMSU College Ranch, and 2 different cows, and there's some patterns between those. So 2 different years, different seasons, but they tended to use it about the same. So that's a week of each one. Some different ones at Corona. There's some similarities, both July, same time period, same things. There's some patterns. Maybe these cows are using some of the same spot similarity. When we do some repeatability, we look at it like by week and things. So one of the things, because the problem is, it's expensive and hard and painful to, and we're always interested in looking at more and more individuals to see what it is. If we look at this by week, so these are the 2 best and the 2 worst cows. And notice there are some similarities across temporally from week to week. So we're thinking that it still is there is repeatable, but it is not perfect. So the last thing is Dr. Thomas is going to probably talk some more about it in the morning, so stand by, but I want to talk to you a little bit. We did a couple different studies. Our last one, we used all the data. We had 13 of our ranches. We looked at 330 cattle for a genotypic phenotypic association study. We used a high density SNP chips, but this one we only used, it, what was it? What was the number we used, Scott? We used, how many genotypes? We didn't use the full set 800, we used, yeah. So we used that, we did an association with Asian, and we had these ranches, and look how different they are. This is just pictures of them. There's some really different ranches on these. But they're all over the West. We were thinking that would make it more robust, and probably robust is good, but sometimes there's too much of a good thing. Sometimes I think we got a little too robust. One of the things is when we did this association study, we found 32 QTL, 29 putative candidate genes for terrain use. And we did a previous study, we had a lot better luck, but we didn't use a Bayesian technique, a more conservative thing for our phenotype genotype association study. Another thing is it's clearly a polygenic trait, and we need to do some more work. And that's what I want to spend some kind of about last of this. Where do we go from here? We were hoping to have a genomic breeding value for this. We didn't get it. Because the problem is, it'd be cool to have a genomic one because we're going to have to put out and track everything with this expensive tracking equipment. We'd have a totally genomic thing, it'd be a lot better. We just don't have it now. Too much variation, a lot of it we think is from having it from the same, using very different data from very different places. So where do we go from here? We got 3 more ranches that we can get a chance to analyze. Gets us up to 440. We're going to probably try to real hard to use this research selection function that we just talked about to try to adjust the MIPS so we can pool that data together. But probably, Dr. Spidell's idea, if we just need money, we need to probably do several hundred head at the same ranch at the same time and do that association study. It may work out. But the cool thing is it's getting cheaper to track cattle. And we should probably do different studies in flat country like we saw here and really rough country. We didn't do that. We pulled them together. It's probably dumb to do that. We probably should separate that. But the thing is, what's happened is, right, is anybody here of supply chain issues? You've heard of it probably, huh? Right? Well, one of the things that supply chain crisis has is to create these cool new little deals right here. Real-time tracking GPS. They're small. It's like a cure. It's so you can slap it on a truck, slap it on a container, and track it in real time and see where it goes. Right? Supply chain is making it, they become much more reliable. There's lots of different ways to do it. We'll talk about that. They're smaller, they're lighter, and they're less expensive. And they're likely to continue to do that. Because I bet with you anything, we're going to be tracking everything moving overseas and within the United States because of our supply chain issues, right? We're going to be doing that. It's going to likely really help that out. One of the ones is that we have uses a low range, wide area network. This sort of a system where you have a transmitter here in a pasture, and then you have a tag on a cow, transmits to the transmitter, and then go from there to the internet, usually by cellular technologies or satellite technologies, and pick it up on your smartphone. So we have one of those. There's commercial ones. One of them is this movement. We've used it in there. We looked a couple different times. They cost about 40 bucks a tag. They're supposed to last 3 years. The antenna costs about 1,500 bucks. We put out a couple of them, and we've had some ups and downs with it. So simply, it's like last seen, some 63 hours, 3 months ago. These were an older generation we had out. A newer generation, we got them. We were talking to them. We're kind of we were complaining, and so we talked to the company. They sent us some more, and we put them out along the fence because the cattle were out. So I tied them on the fence, and then this last generation is working really pretty good. So if you look at some of those, like 89 minutes ago, they're supposed to take them every 2 hours. They seem to be working. So the message is this technology is getting better and better all the time. But sometimes there's some issues. Another one that worked really pretty well, this is from a Spanish company. It's called Digital Animal. We bought some. There's cost $7.75 for 5 collars. They take a position every 2 hours. They rely on cellular transmission. So every 2 hours it takes a position and transmit it. If it has contact, if you have cellular reception, it sends to the internet, you get it. And you get some really cool tracking stuff. You can see right where they've been. There's some data from it. We had 5, I bought the 5, put them out in the same place, and you can see where they all are, and then you can look at the individual track from those real easily, and quick. They can send you all the data you have every week. Every week we upload dates, so you have the whole data set, or you can look on your smartphone and see where it is. But it worked pretty good. But this is in a spot right next to Prescott, Arizona. Excellent cell phone coverage. It worked like a champ. Here's one we tried out just north of here, up in the mountains west of Hatch, New Mexico, up the road about 30 miles, then up in the west. This is the Mojave Sierra Alta Ranch. And it's close to I-25, so there is some cell phone things. But in this is really rugged country. You can look from the map, we're using it. It's really rough country. But when the cattle are up high, they get cell phone reception and transmit it. It keeps taking the position a little bit. This is that digital matters. We got it from Lone Star Tracking. And you can really see some differences there. So, but one of the things that's cool about this data is notice this cow. She goes out and comes back in. And so the reason, why does this happen? Keep an area, this is the west. This is a BOM allotment. It's got a nice gate to let people through. There's a county road, actually, a county maintained road that goes through there. Don't take your Cadillac through it. It's a little too rough for your Cadillac, but you can drive a pickup through there. And that cow went out, came back in by herself. The rancher that has the permit, the Mobleys, he saw, I said, God, I better go out there and look at that. Some of those cows might not came back in. Somebody left the gate open. Cows got out. This one came back in. He was going to see if his cows were out in the neighbors. So this data has other values. So why that's why this whole thing may change. That's why I'm going to give you the update. Because real-time technology have lots of different values. Let's talk about some more. Here's another one. There's one instead of most GPS is calculated. The position is calculated on the device. Here's one where it stores the pieces and then does it later. It does a cloud-based solution for the positions of the satellite. It's a little supposed to be better battery. It didn't work. It still lost its battery, but you get really good tracking records of it that can work. And so you know where this heifer is. So there's a lot of value besides this genomic stuff that we may be able to incorporate in and finally get something for this idea. Here's the last one, which is really the coolest yet. One of them is a Sears tag, but the downside is it only gets 4 positions a day. But it has an accelerometer in between. And I think maybe 4 positions a day are enough. I don't know. We're going to find that question out. But you can, for $4 grand, you can get 24 tags. It should last 3 years. You just got to buy a $500 applicator. You can't use your own ear tag applicator because that applicator turns it on. It has 2 prongs, but it works a position, everything, and it goes via satellite. The other one is here. This other one here from Lone Star Tracking. There's other companies that are using the same stuff, and you can get probably in about hour intervals. 3 years, probably about $300 a tag. Right now, maybe it'll go down someday. That's expensive, but it would work anywhere, because it transmits the data via satellite. You don't need it. You don't need towers that have line of sight issues. You don't need cellular reception. All you need is a relatively clear sky to transmit the position. It is really cool stuff. So the thing is why am I talking about this? Because if you have other values, maybe then we can start gathering the data for this phenotype that's so expensive and painful to collect. The first thing is I just want to show you one example. So we talked about a lot of nutrients, Eric. Water is still the most important. Crude protein, energy, always important. Water is the most. The problem is we spend a lot of time checking cows' water, a ton. And it's a big labor requirement. When you get to like 61,000 acre ranch, you can spend a lot of time driving around looking for that. A lot of time looking around. So the thing is, wouldn't it be cool if we had a way to remotely check that? One of the ways is if you have on-animal sensors, you can get sensors, you can take game cameras to take a picture of it. You can put float valves that send the valves up, but the animals themselves can tell you a lot. So here's just an example of that. So check the typical watering event. Animal comes cruising in, the white dots come in, gets a drink, and this had one water source, 3,000 acre pasture, takes a water source and then slowly wanders out and goes, lays down and ruminates and rests in the heat of the day. Usually once a day, there, maybe every 2 days, maybe every 3 days, not multiple times per day. One time a day, maybe even once every other day. But if that water is not there, so we did a simulated water failure, the animal goes to there and stays. And when you go think about, if you go check cattle, if you see cattle gathered, a whole bunch of cattle gathered around a water tank in the middle of the day, that is not a good sign. That means pumping skills are needed soon, because it has failed. And so when you look at the data, you look at the difference in distance from water after entering this area. This one had a water lot, about 150 yards by 100 yards. So if you see that, normally it comes that after entering, they quickly leave. If they don't, it stays closed. The only variation is on when they came in. So that's the thing. A second thing is, remember I was talking about riparian areas? Riparian areas are a big deal on public land allotments. Most of the issues are associated with riparian areas. A lot of the special species, threatened and endangered species, often around riparian areas. Cattle tend to like to hang out there, right? Because it's got water, shade, and green grass, as opposed to uplands. So what if we could monitor that? Here's the thing, is there's some differences. Here's some data we collected in California. Some cow, like this, the cow 2093 didn't hang out there, others were camped on it. So if we could, maybe we could use that to measure how much time there, and also find out how much use is there. Now, this is the same ranch where we were measuring, there is relatively flat. We measured it from June to October. We tracked the majority of the cows in each herd. They have two herds on each side of this highway, Highway 89. This is right by Prescott, Arizona. And it's pretty good size. It's like 3 miles from water. These cows did not listen to Holechek's paper. 3 miles from water for these Corriente cows is no big deal. Very uniform distribution. So we were trying to see if we could use the points to predict the actual amount of utilization. So we could use the tracking data to predict how much use is one spot to see if there's a problem. We did hotspots analysis of it, which is a real cool there's a concentration. And so when the cattle were grazing, it's pretty uniform. The only hot spots there are places where there was water or supplement. And when they were resting, they tended to hang near water. So we did this analysis, and so if you look at this is like the density. We split it up into areas nearby, like within about a 2-acre area around each place where we measured utilization, and tried to do an analysis, and we didn't get nothing. We weren't able to predict the forage utilization, very poorly, but the utilization was not much, and the distribution was really uniform. So we had a terrible time predicting it. When utilization is good and uniform, it's not too surprising, right, that you can't get a good relationship between a good predictor of it, because there's no spread, and there's no real problem. We did another one that using some data we had in Montana where we did a herding study. So we're trying to show that herding would make a difference to change where livestock grazed. So we did that. So we had some real differences in this study. Cattle were hanging out by riparian areas and not using areas far from water unless we were herding them. So it was a kind of a good spot to do that. And so one of the things I want to do, we did a hotspot analysis of that. And if you go back and look at this, hotspot analysis work. If you look in this corner, there's an irrigation ditch with some associated metal by it. Go back one. Want to go back one. Why doesn't this go back?
Can you just arrow up?
Huh?
Arrow up.
It is not arrowing up. It's not arrowing up. And going backwards worse.
You're done.
I'm done.